Everyone. In this video, we will talk about the electromagnetic radiation and the electromagnetic spectrum. First of all, let us start by defining the word radiation. Radiation is a form of energy that travels and spreads out as it goes. In our life, we know so many types of energies. There are potential energy, kinetic energy, chemical energy, and so. Radiation is one of these forms, which is characterized that it travels and spreads out as it goes. So this is the definition of radiation. Moving to the electromagnetic radiation. If you want to think of electromagnetic radiation, directly it clicks to our mind light, because we heard this word a lot. Light is an electromagnetic radiation. How it is described? It can be described in terms of a stream of massless particles called photons. Each photon travels in a wave-like pattern at the speed of light. And we know that the speed of light is equal to 3 times 10 to power 8 meter per second. C is the speed of light. So electromagnetic radiations, they travel in vacuum with a speed of light 3 times 10 to power 8 meter per second. This is the wave that they travel by. We will discuss it in details in the second slide. The difference containing certain amount of energy. Energy is very important. Why? Because the different types of radiation defined by the amount of energy found in the photon. So each electromagnetic radiation has its own energy that differs from the other. For example, radio waves have photons with low energies, while microwave photons have a little more energy than radio waves. Infrared photons have still more. Then comes visible ultraviolet X-rays. And the most energetic of all of them, gamma rays. Now let us describe in details this wave. We said that the photons, they travel in wave-like structure. They are electromagnetic radiation that consists of electromagnetic waves. If we have to look at this figure, X represent the electric field, while Y represent the magnetic field. And this is the propagation line where the wave propagates. The blue lines goes for electric field, and the red lines goes for magnetic field. Electromagnetic radiations consist of electromagnetic waves, so electro and magnetic, which are synchronized oscillations of electric and magnetic fields. They act at right angle triangle to each other and perpendicular. They act, both of them, perpendicular to the direction of propagation of the wave. That's why we say that these electromagnetic radiations are transverse wave. A transverse wave is a wave in which the medium vibrates at right angle to the direction of propagation. Electromagnetic wave, also we can call it a linearly polarized sinusoidal. What's the meaning of linearly transverse, as we said? Polarized. What's the meaning of polarized? Polarized, these are waves in which the vibrations occur in a single plane. So this is the plane that they occur in it. Sinusoidal, because they oscillate and make a wave in the sine function wave. So a sine wave or sinusoid is a mathematical curve that describes a smooth periodic oscillation. It's named after the function sine, and it is a continuous wave. If we have to think of sine wave, this is the shape in the red color. This is the shape of the sine wave. It's continuous wave, in a continuous wave. Electric field. we spoke about the electric field in the wave. What is an electric field? An electric field is the physical field that surrounds electrically charged particles. These are the charged particles, and this is the field. These lines are coming out and in. These are the lines that represent the electric field, either attracting or repelling. So an electric field is the physical field that surrounds electrically charged particles and exerts a force on all other charged particles, either by attracting or repelling them. We spoke also about magnetic field. In magnetic field, we have poles, north and south. When I talk about magnetic field, it clicks into my mind the vector. So a magnetic field is a vector field like this one. This is portion of the vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetic material. A moving charge in a magnetic field experiences a force that is perpendicular to its velocity and to the magnetic field. Now, we described in details the shape of the wave and its function, sinusoidal. Let us move to the electromagnetic spectrum. What is electromagnetic spectrum? It is the range of all types of electromagnetic radiation that we mentioned already. Microwaves, visible, gamma rays, X-rays, radio waves. So it is the range, this is the range of all types of electromagnetic radiation. In this chart, they are represented and they are arranged, these electromagnetic radiation, as per increasing wavelength from left to right. From left to right, lambda wavelength increases while, lambda decreases. From left to right, I'm talking about from left to right. We see that the wavelength decreases while frequency increases and energy increases. Why? Because we know that there is a relation between frequency and lambda, that they are inversely proportional to each other. So the frequency nu equals C over lambda. So frequency and lambda inversely proportional to each other. So if lambda decreases from left to right, it means the frequency increases and hence the energy increases as well. E equal H nu. That tell us that the energy is directly proportional to the frequency. And here the frequency inversely proportional to the lambda. Let us talk about day-to-day life electromagnetic spectrum in our day-to-day life. Let us take some informations about these electromagnetic radiations that we explained. For example, radio waves. Your radio computers captures radio waves emitted by radio stations. Radio waves are also emitted by stars and gases in space. Microwave radiation will cook our popcorn in just few minutes, but it's also used by astronomers to learn about structure of nearby galaxies. Infrared night vision goggles pick up the infrared light, helps us map the dust between stars. Visible radiation, our eyes detect visible light. Fireflies, light bulbs, and stars all emit visible light. Ultraviolet radiation is emitted by the sun and are the reason of skin tans and burns. Also, hot objects in space emit ultraviolet radiation. Another type of electromagnetic radiation, X-ray. A dentist uses X-rays to image our teeth, and airport security uses them as well to see through our bags. Hot gases in the universe also emit X-rays. Gamma rays use gamma ray imaging to see inside the body. The biggest gamma ray generator is the universe. We have two types of spectra, continuous and line spectra. If we have to take a look here, like this one, white light hit the prism. When it strikes the prism, it splits into the colors of the rainbow. And as you see, no gap in between the colors. It is a continuous spectrum. Line spectra, there are two kinds of it. We have emission spectrum and absorption spectrum. What's the difference? We will see in the next slides. Here, hot gas passing through the prism. As you see, line spectrum obtained, and they are bright in color. While in the absorption spectrum for the cold gas, it's hitting the prism, we see dark lines obtained. Let us see the difference between, first of all, line spectrum and continuous spectrum, and between the line spectrum emission and absorption themselves. For example, look here, 5,000 Kelvin, the background 6,000 Kelvin. Here down we have 5,000 Kelvin, background empty space. So type of spectrum seen depend on the temperature of thin gas relative to the background. If we have to look at the top, thin gas is cooler, this one, than the background. So this gas is cooler than the background. So absorption lines are seen. If we have to look at the bottom, the thin gas, this one, is hotter than the empty space because the empty space has low temperature. So in this case, emission line spectrums are seen. Continuous versus line spectrum. Let us see the differences. First of all, continuous spectrum is the superimposed image of both absorption and emission. It means for the same element, definitely, because each element has its own line spectrum. If we superimpose these two, they give the continuous spectrum. Line spectrum is either an absorption or emission. So this is the difference. So this continuous spectrum is the superimposed image of both. We said absorption and emission. Line spectrum here, on the other hand, either emission or absorption. As you see in the continuous spectrum, no observable gaps. You see the colors all after each other, no gaps in between them. But here in the line, there are gaps. Look, in the line spectrum, we see gaps. Continuous spectrum contain all the wavelengths of a given range, like the visible light and the black body. While they contain only line spectrum, few wavelength. For this line there is wavelength, for this line there is wavelength, while here it contains all the wavelengths of the visible light. Rainbow and black body radiation are examples of continuous spectra, as we said, or spectrum, while emission spectra of hydrogen and absorption spectra of hydrogen are examples of line spectrum. Now let us see together the difference between atomic absorption and flame emission. In absorption, it measures the radiation absorbed by the unexcited atom. So in the absorption spectra, you see these black lines because it's measuring the radiation of the unexcited atom, while these bright lines in the emission spectrum measures the radiation emitted by excited atoms. Secondly, atomic absorption depends only on the number of unexcited atoms, while on the other side, the flame emission depends only on the number of excited atoms. The third difference, absorption intensity is not affected by the temperature of the flame in the atomic absorption, while the emission intensity is greatly affected by the variation of the flame. These are series, Lyman series, Balmer series, obtained from the electron transitions for the hydrogen atom, Paschen series and Pfund series. When the electron goes from any energy level down to energy level 1, we see these series. We call them Lyman series. This is ultraviolet spectrum. While when electron goes from energy level 3, from any energy level, down to energy level 2, Balmer series obtained, which is the visible spectrum. On the other hand, when electron goes down from any energy level to energy level 3, obtaining Paschen series, infrared spectrum. And electron going down from any energy level to n equal 4, bracket series obtained.